This video is going to be an application of related rates through triangle problems, through right triangle problems. So if you ever get a related rate problem that seems like it's dealing with a triangle, like Pythagorean theorem type problems, or maybe you have a wall and a ladder is stacked up against the wall and the ladder is sliding away from the wall and like a man is sliding down the wall, that's a right triangle problem. Sometimes you have two convoys that are leaving a train station. One's going north, one's going east, and you're talking about the distance between them changing. That's a triangle problem. Maybe sometimes you're talking about an airplane flying past a person on the ground. So maybe the airplane's here, and then the airplane is here all of a sudden. And it talks about something about the distance between them, this distance right here, changing. That's a right triangle problem. So there are many kinds of problems that present themselves like this one. And I'm going to sort of write a problem up here, and then I'll come back and teach it. This is a pretty typical related rate problem, talking about the bottom of a ladder sliding away from a wall. So I might have a building here, and a ladder is leaned against the building, and the ladder starts to slide away from the building. Oh no, a person's going down the building, the bottom of the ladder is going away from the building, so you can see how this would be a triangle. It gives you the rate, so if this is an x and a y, the rate at which the ladder is sliding away from the wall, this rate, 3 feet per second, is dx dt. Notice that this rate is positive, that's because the ladder is sliding to the right, away from the wall. So the ladder is sliding down the wall, which would indicate that dy dt is a negative number, because the ladder is going down the wall, which is how fast is it sliding down the wall. So I know I should get a negative answer at the end. And what else about this problem? I see that I'm talking about at the instant when the ladder is 5 feet from the wall. So at x equals 5, we'll call this c up here, sort of like Pythagorean theorem, a squared plus b squared equals c squared. We know that this distance is always 49 feet. It's a 49-foot ladder. So that's just some information about this problem. And you can see that I have two rates, and these rates are both changing with respect to time. What that means is this one changes to the right and this one changes down as time goes on. And so the first thing about a related rate problem is to find an equation that relates all of these rates. And the equation for these triangles, the right triangle, is Pythagorean theorem. So here's the Pythagorean theorem for this problem. First thing you need to do is differentiate. You've got to differentiate first. If you don't, you can't just go straight to sticking all these numbers in here. So differentiate everything with respect to t. So this would be 2x dx dt plus 2y dy dt equals 2c dc dt. Okay, then you plug in what you know and you realize what you're looking for. How fast is it sliding down the wall? So I know I'm looking for this one, and I just need to try to figure out what all these pieces are, because I'm only allowed to have one unknown at a time, and this is my unknown that I'm looking for. So we know that x is 5. See, at the instant when I'm 5 feet from the wall, that's this right here, this is a 5, so 2 times 5. dx dt, we said at the beginning, was positive 3, plus 2 times a y coordinate. How would I find this y coordinate if I knew that this was 49 and this is 5? At this instant, the Pythagorean theorem would work. Y squared plus 5 squared equals 49 squared. So y squared equals 49 squared minus 5 squared, which is 2,376. And so y is whatever the square root of that is, 2376. Okay, so that number goes right here. So let me make these parentheses bigger. Okay, this is 48.7. I just did it in a calculator. dy dx is what I'm finding. 2 times c is 49, and dc dt, the rate at which this distance is changing, this distance is not changing. So the rate at which this distance is changing is 0. So sometimes it's very important to know that one of your rates may not be changing. See, the rate that this ladder shrinks or grows, this ladder is not shrinking, it's staying 49 feet. So dc dt is 0. It kind of helps us in this problem. So this would be 30 plus 2 times 48.7 times dy dt, which would be 97.4. dy dt equals 0. And then move the 30 over here, divide by 97.4. And whatever you get for this decimal number is what you get. And notice we do have a negative answer here, and that's good because y is going down. So this is approximately, let me do this in a calculator, it's approximately negative 0.462, and we're talking about feet per second because my units are feet and my time units are second. So that's one way to do a related rate problem. There are many related rate problems. Each one's all the same, but they're all different. They're all a different equation to start with, but after that the process is the same. So I'll do another example maybe in a different video.